controlled converters. Myself, Dr. Balamurugan, working as an associate professor in the Department of EEE, K.S. Rangasamy College of Technology. So, in the coming slides, we are going to discuss about what is controlled converters, what are the applications, what are the different types, how it will be working, what are the types of loads, like that. Let's be discussed. So basically the classifications of phase controlled converters are single phase and three phase. So in single phase we will be having semi converter, fully controlled converter and dual converter. Same way, same type of classification is for three phase converters. Semi converter, fully controlled converter three phase, dual converter three phase. Semi converter is basically a one quadrant converter and it has only one polarity. And fully controlled converter is a two quadrant converter and its polarity will be either positive or negative. However, the output will be in one polarity only. Output current will be in only one polarity. So come to the dual converter, it will be operating in four quadrants and output voltage and current either it can be positive or negative. So this is a half wave controlled converter. Here the controlled switch we are using is SCR. By the gate we can control the output of this converter. Here we are connecting with the resistive load, so the voltage and current will be in phase. So this is the input supply I am giving to this controlled converter with the help of a transformer. So this is nothing but source current, this is nothing but output voltage V0, this is nothing but input voltage Vs. So you can see the output voltage waveforms which is shown here. After a firing angle alpha, my output voltage will be coming. So current which output current is followed by the output voltage. So this is for a half wave. So negative wave there will be output will be 0 because here when I am giving the positive supply, this device will be forward biased and my output will be coming. So when the negative supply is entering into this device, the device will naturally turns off and my output will be 0. So this is the gate pulse which is given at the time. Next we will see the average output voltage equation. For this half controlled converter is Vm by 2 pi 1 plus cos alpha. Here the duration of conduction is alpha to pi. So we have to integrate it with respect to the sinusoidal supply which is given at the input. So maximum output voltage can be given as Vm by pi and RMS output voltage is given in this formula as Vm by 2 root of 1 by pi into pi by pi minus alpha plus sine 2 alpha by 2. So this is a small problem which we have to find out the rectification efficiency, form factor, ripple factor, peak voltage PIV of the thyristor. Here firing angle is pi by 2. Pi by 2 is nothing but 180 divided by 2 is nothing but 60 degree. So you have to calculate by using the same formula which is already I have given. You can see the formula we know Vd is equal to Vm by 2 pi into 1 plus cos alpha. Here alpha I am substituting as pi by 2. So we are getting the Vdc as 0.1592 Vm. So we have to calculate it by Vrm and efficiency can be given as Vdc square divided by Vrm square. So we can get the output efficiency as 20.27%. Same next problem I have given. So you have to in the same problem we have to find out the form factor. Form factor is nothing but Vrms by Vdc. So it's nothing but 2.221. Next ripple factor. Ripple factor is nothing but square root of form factor square minus 1. So already we find out form factor. So we have to subtract it. The last one is peak inverse voltage which is nothing but the Vm. Vm is nothing but root 2 into Vs. So next we are going to say about the semi converter. So semi converter in the sense the controlled operation will be semi. So this is the semi converter construction of a circuit. So here we are using 4 number of switches. So in the 4 numbers, 2 number will be a thyristor, 2 number will be a diode. For every off cycle, 2 devices will be conducting. And you can see for the first positive off cycle, I am giving a sinusoidal supply as Vs. For the first positive off cycle, T1 and D2 will be conducting, and the negative it will be turned off naturally. and when the negative, for the negative half cycle, T2 and D1 will be conducting. So you can see the output voltage here, output voltage V0, which is nothing but here for after the alpha, the output will be coming like this. This is nothing pi plus alpha. So here you can see T1 and D2 will be conducting in this period. So here semi conversion with the help of semi-controlled switches. Here one switch will be a controlled, other switch will be a uncontrolled switch. So we are terming a semi-controlled converter. Awfully controlled, awfully uncontrolled. So we can say this as a half controlled converter also. So the output voltage waveform which is shown here is nothing but for a firing angle alpha. So this is nothing but a thyristor current, and this is the two current, that is thyristor current during the conduction, and this is the diode current during the conduction. So this is the supply current and this is the output current I0. So the quadrant operation is nothing but positive VDC and positive IDC. So quadrant operation is a single quadrant. So these are the output equations. Vm by pi 1 plus cos alpha. My RMS output voltage is nothing but 2 by 2 pi alpha over the pi Vm square sin square omega t d omega t within the square root. So mode 1 is calculated for 0 to alpha. Mode 2 is calculated for alpha to pi. This is nothing but conduction period. These are the some values of current RMS value and RMS output voltage and also average output voltage equation. This is the problem for semi-converter with RL load. You can see you have to find out the load current, average thyristor current, RMS thyristor current and RMS output current. Here L value is given, R value is given, E value is given, Vs is given at 60 volt. And average output current also you have to find out. The formula you have to find out these parameters. So next thing you are going to see about the fully controlled converter, which is nothing but two quadrant operation, and you can see the circuit diagram which is shown here. So compared to the half controlled converter, in fully controlled converter we will be having a 4 number of switches with controlled thyristors. For positive half cycle of input, T1 and T2 will be connecting, and for negative half cycle of input, T3 and T4 will be connecting. So here you can have a load as RL load, and E is also connected added with the RL load. So we can see the output for RL load. So for positive half cycle, T1 and T2 will be conducting for an alpha. After conduction of these two switches, when T3 and T4 is ready to conduct, at the time the inductor stored energy in the inductor will get discharged. So in positive half cycle conduction, T1 and T2, the inductor will store the energy. So during the natural commutation of T1 and T2, the polarity gets reversed and the inductor starts discharging. So due to the presence of inductor charge, these two devices will not get commutated and it will be conducting over a period of pi to pi plus alpha. This period we call it as a discharging period of the inductor, and during this period the inductor will get fully discharged and it will reach to 0. After that T1 and T2 will get commutated naturally. Next we will be giving the firing pulse to T3 and T4. The same will be continued for the consecutive cycles and it will be repeated for the another cycles. So here when the firing angle is below 90 degree, I can operate this rectifier as an rectification mode, and when firing angle is increased beyond 90 degree, I can make this rectifier will work as an inversion or inverter or line commutated inverter. So this is the output voltage waveform. You can see here negative portion is also shown in the duration of pi to pi plus alpha. And you can see the quadrant operation. We can get positive voltage for the first quadrant, positive current, and this current will be positive, but the voltage will be negative in the second quadrant, which is nothing but inversion mode. It gives the two quadrant operation. So the output voltage equation we can see is nothing but average output voltage 2 Vm by pi cos alpha. And we can see the RMS voltage also Vm by root 2. And these are the mode 1, mode 2 operations, which gives the, which when connected with RL load. And RMS current of thyristor calculated as shown in here, and average output current is also shown here. You can see IDC, IRMS, and IA and IR. Next, we are going to see about the dual converter. So what is dual converter means? We will connect two types of converters. The same what we have explained in single phase. This is nothing but a single phase rectifier. When the switches are connected like this, we can say it as an inverter. So this is a 4-quadrant converter. So when I am connecting like this, I can have a single quadrant operation. When I am connecting like this, I can have a dual converter operation. So for a converter 1, the output will be coming like this. So with respect to the circulating current and non-circulating current mode, and here inductor is connected in series with converter 1 and converter 2. So the output voltage will be, for in converter 1 it will be like this, for converter 2 the output voltage will be inverted. So this is the output voltage equation V01 for converter 1 and V02 for converter 2. So it will be in opposite direction because we will be getting an inverted output in the second converter, that is nothing but we call it as the inverter. So that's all about the operation of a dual converter. Average output voltage equation for first converter and second converter is displayed here. You can see main application of this dual converter is variable speed drives. The next 3-phase semi-converter, same policy is followed. The construction is somewhat different from the single phase because here we have to connect with 3-phase and 3 number of switches for each type of leg. There only we will be having a 4 number of switches for single phase. Here it is a 3-phase semi-converter, will be having a 3 number of switches, which is a controlled switch, and 3 number of switches in the lower leg, which is a uncontrolled switch. So it gives the output. This shaded region will give the output for phase to neutral voltage. So usage of the phase control rectifiers. It can operate in 3-phase AC supply. They produce higher DC output voltage which can be used for industrial purpose. So filtering requirements are simplified because of output voltage and output current which is working in a 3-phase control rectifiers. Output voltage ripple will be can be easily reduced. So thank you. That's all about the control rectifiers, and thank you for giving this opportunity.